Hello and welcome to Tech Simplified TV. In today's episode, we will discuss about different job roles and their scope of work in VLSI. If you are a fresher or planning to join the domain, this video will help you. So, stay tuned till the end of the video. Let's get into the topic. First, design engineer. Design engineer is a job role where the engineer designs a brand new circuit for an upcoming chip or modifies an existing design already realized in form of a published chip. In VLSI, we design fresh chips as per need. Hence, we have to start a design from scratch. Here, the need of a design engineer come into the picture. Design engineer can work at SoC or chip level, sub-chip or subsystem level or IP level. Now, let's discuss about the different design engineer roles we usually see across entire VLSI arena. First, RTL design engineer. They design a particular digital circuit using HDL. They take help of state machine to capture and incorporate any novel digital design. The job role may include the responsibilities like designing the functions of modules of the system on chip as per input and output specification, optimizing the design to achieve best power performance and area, implementation and verification of high performance and low power clock distribution network and building blocks. Second in the list is physical design engineer. Physical design engineer has to work on the chip layout. The work may start from floor planning and may go up to engineering change order. Third, IP level design engineer. Design at the very block level with basic functionalities. The nature of design could be digital, analog or digital plus analog, that is mixed signal. Number 4 is the digital design engineer or architect. Such engineers are responsible for defining and realizing digital functions on IP, subsystem or IC level based on required specification. Number 5, analog design engineer. If the IP and the design is analog one, then we call them analog design engineer. Different types of memory design comes under analog design. Second type of position is verification engineer. Well, after design engineer post, let's understand about verification engineer. When a design is made by a design engineer, it has to get verified for its intended functionality with all sort of possible permutation and combination of input and control signal values. Hence, the need of a verification engineer comes into the picture. Depending on nature of the circuit and methodology of verification, we can further divide job roles into digital verification, analog verification, AMS verification, and DFT. Verification engineers design and implement testing procedures to determine if products work as intended. These skilled engineers are responsible for creating the initial product verification methodology, selecting the testing environments and developing testing plans. First, digital verification. The digital verification engineer operates before the FPGA ASIC or SoC production phase. He works with the design teams, that is FPGA engineers or microelectronic engineers, etc. in order to verify their designs, that is IP, subsystem or system. The verification can be realized at different abstraction level. RTL unit blocks verification. The verification can be made at the RTL blocks level. Thus, we test all the functionalities of an IP through simulations. Verification at the subsystem level. The verification can also be realized at the subsystem level, including several IP. Then we check all their functionalities and their integration in the subsystem. Third is top level verification. Once the RTL design is verified at the unit level, we can integrate it at the top level. Required skill for this kind of position includes skill in ASIC or FPGA verification, basic knowledge in design techniques Verilog or VHDL, a good knowledge of simulation flow, good understanding in scripting, Python, Perl, Bash, etc. Second type of verification is analog verification. Analog verification is a methodology for performing functional verification on analog mixed signal and RF integrated circuits and system on chip. Third is analog mixed signal verification, a single verification environment combining both analog and digital solvers that can be used to functionally verify at the desired level of accuracy using their option or both digital and analog engines. Metric-driven verification to analog components in a mixed signal design. Number 4 is DFT. Above mentioned 3 verifications are pre-production, whereas DFT is done after production of the chip. During the design process, extra logic is put in the design which actually used to do post-production testing. The purpose of DFT is to validate or verify that the end product does not contain any manufacturing defects. After verification engineers, next in the list is PD or Physical Design Engineer. Moving to physical design means moving from abstract level to silicon levels. So actually all the engineers look to the design through lens of silicon. Physical design or backend starts after synthesis and includes step up to sign off. So basically floor planning, placement and routing, timing or STA, power budgeting and area implementation, ECO task, that is timing and functional ECOs to address functional bugs and timing violation, physical verification like LVS, DRC, etc., noise analysis, electromigration, antenna checks, all this comes under job role of a PD engineer. Obviously, it should be a big team to perform and complete all these complex works. Required technical and professional expertise for a PD engineer includes good knowledge and hands-on experience in physical design methodology, which includes logic synthesis, placement, clock tree synthesis, routing. It's expected that the candidate should be knowledgeable in physical verification, that is LVS, DRC, etc., noise analysis, power analysis, and electromigration. Good knowledge and hands-on experience in static timing analysis, good understanding of timing constraints, automation skills in Perl, Skill, or Tickle are expected. Strong background of ASIC physical design, that is flow planning, PNR, extraction, airdrop analysis, timing and signal integrity, closure, etc. Extensive experience and detailed knowledge in Cadence and Synopsys or Magma tools are much preferred. Expertise in scripting languages such as Perl, Tickle, strong physical verification skill set, etc. are required. After physical design engineer, next is application engineer. Application engineer works at the customer interface. They both take care internal and external customers. It doesn't mean to meet the customer face to face always. There is a continuous communication via mail or ticketing system. They take care of customer needs. Let's understand this from perspective of a EDA tool vendor. An EDA tool company sell its products or tools to many design houses. Every company wants to make their tool bug free, although all tools have some bug. When the engineers from design team of some other company face any issue regarding the tool, they get back to the EDA tool vendor and application engineer from EDA company look into the issues. Then the application engineer take R&D team in the loop and give solution to the customer. This is basically post-sale position. In some cases, application engineer post is pre-sale position and their job role includes visit to customer campus. In such visit, actually they meet new teams, try to understand if there is any requirement where their EDA tool can fit. If a FAE can take up any lead and convert it into sale, then the matter goes to account manager and sales executives. This job role requires communication skills including written, verbal, through WebEx, Zoom or Google Meet. Field application engineer, corporate application engineer, application consultant are some popular designation of application engineers. The job title depends on companies. This kind of job role gives you satisfaction of solving problem, high stress of handling demanding customers, glamour of traveling, and obviously you will get amazing experience of people interface. Fifth job role is CAD engineer. CAD engineers are expert in CAD tool and they develop flows that integrate multiple tools, creating a rather seamless environment for other engineers to use. Develops and applies computer-aided design, software engineering methods, theories and research techniques in the investigation and solution of technical problems. Assessing architecture and hardware limitation, plans technical projects in the design and development of CAD software, defines and selects new approaches and implements of CAD software engineering application and design specification and parameters. They develop routines and utility programs also. Prepares design specifications, analysis and recommendations for presentation and approval, may specify materials, equipment and supplies required for completion of projects and may evaluate vendor capabilities to provide required products or services. Required technical and professional expertise like good knowledge of scripting languages like Python, Tickle, Perl, exposure to C, C++ or other functional programming languages, experience in different commercial tools, good understanding in VLSI domain, familiarity with standard software engineering practices for version control, configuration management, testing, root cause analysis, and quality assurance. Teamwork, communication, and problem-solving skills, in-depth knowledge in data structure, algorithms, and optimizations. For CAD engineer, it is advisable to gather as much as domain knowledge possible in the area of working. Sixth in the list is characterization engineer. There can be various types of characterization in the entire VLSI arena. At the very basic point, characterization means to list out the electrical properties and or associated physical properties associated with a circuit under concern. Now, by the nature of the circuit, whether it's digital, analog, I/O or memory, the definition of respective job role is defined. For the characterization, there are generally industry standard simulation tools are there. If you are going for such a job role, you have to learn respective EDA software. For standard cell characterization, Cadence, Liberate or Synopsys Silicon Smart are most popular to EDA tools. For memory characterization, whether you are designing a RAM or ROM or NVM or any other memory, generally there are a lot of custom scripts combined with professional EDA tools which will be given to you. For such characterization jobs, strong fundamental knowledge of the respective circuit is required. Seventh job role is Silicon Test Chip Engineer. Test chip is a functional miniature prototype of the ASIC chip under concern, or the test chip could be a test vehicle to test various design IPs of a IP design house. The test chip engineer has to be a jack of all trades. He or she must know all the steps from RTL to GDS2, and hence the test chip engineer job role is challenging and highly rewarding. Eighth in the list is sign-off engineer. You might come across the name sign-off engineer. However, for you freshers, we would like to tell you that these positions are not for freshers. When you have at least 10 to 15 years of continuous experience, then only you can look towards this job. Well, we have discussed in a generic way about some popular job roles in VLSI. These are the very basic information, not in very much in-depth analysis. If you want to know in detail about different steps of VLSI in a nutshell, follow our FAQ series. Playlist link is provided in the description box. You will get a fair idea about the flow. Let us know whether this video helped you. Don't forget to share your question or comment. Don't forget to visit our technology vlog techsimplifiedtv.in. That is much for today. We will be back with another episode of Q&A. Till then, stay tuned, stay focused.